Assalamualaikum warahmatullahi wabarakatuh and good day to both of our esteemed panels, Professor Madya Muhammad Arif bin Mat Hanafiah and Technologist Muhammad Azmi bin Said. My name is Muhammad DANISH bin Muhammad NAZRI and I am from 4BEY. My bachelor degree project title is Design and Simulation of a Solar PV Microgrid for Sarawak Rural Areas using Excel Vlookup. First and foremost, let me start the presentation with my project introduction. Nowadays, people have realized that concern of renewable energy for daily life. Installing renewable energy as a main source for our daily use, such as PV solar, was stated in Sustainable Development Goal 7 mission. Next, a microgrid is a set of interconnected loads and distributed energy resources linked or separated to a centralized grid and built to link and detach from it. Microgrid is one of the best solutions to electrify all the rural areas with full electrification. Besides, microgrid with solar PV panel have the added benefit of delivering clean and cost-effective electricity. When the grid is down, microgrid can provide localized power for an extension period of time using a solar PV as a generating source. Next is problem statement of my project. First, the state of Sarawak has the lowest energy coverage in the rural area as compared to the other state in Malaysia. Second, consumers in Sarawak rural area have limited access to electrify due to the geographical difficulty of installing transmission and distribution system to deliver electricity from the main grid. And third, the cost of installing transmission and distribution system does not offset with the amount of electricity consumption. Basically, I have three objectives for this project. First objective is to design and simulate the solar PV microgrid for Sarawak rural area using Excel Vlookup. Second is to calculate the output using Excel and display the electrical parameters, analyze solar PV generation source and energy storage system and load demand for this project. Third objective for this project is to analyze meteorological parameter, which is solar irradiance and electric power forecasting by solar PV microgrid with Excel formula. Next is the methodology of my project. In this topic consists of three parts. It is block diagram, flowchart and PV microgrid design using Excel. First is block diagram of my project. The block diagram consists of three parts, which is input, process and output. For the input, this project has one main input, which is PV solar panel, and the energy will store at battery system storage. For the process, the inverter will convert from DC to AC power to supply the electricity to the rural area. And lastly, for the output, the household electrical load is the output for this project system design. Furthermore, is the flowchart of my project. The project started with when consumer declare the total of electrical load to justify the total solar power needed for the system. The electrical load was very important to optimize the solar panel details, inverter and battery storage detail with their calculations. Both solar panel and battery system detail is to make consumer easy to decide the best solar panel design for the rural area. The size of inverter also taken part in the system to convert the DC output from the PV panel and battery to AC output for the electrical load. Last but not least is my project overall system design. For the project design, the PV panel, battery storage system and inverter act as the main component in the project. Both of the PV panel and battery connection will choose by the consumer either series parallel or series parallel. Before that, the consumer need to clarify the total of electrical load by each household in the Excel sheet to calculate the size of PV panel needed. It is important to make sure the total solar power needed is lower than total solar power produced by the system with the total of daily sunlight entered by the consumer. The result and analysis I have gained for my project is, as you can see there, 4 figures in the poster. The first two figures is testing load of 70 kW for 10 household, solar PV detail, size of inverter and battery system detail. All of the data are the average load details that can be collected in the past few months. Firstly, the performance of this project implementation has been discussed. Some of experiment and testing load have been done to fully investigate the overall performance output for this project. The output for the project was satisfactory because the energy produced by the solar panel is more than the energy needed in the system. In general, the system accomplished all the objectives. For figure 4.1 and figure 4.2, show the calculation of the total load for 10 households with the solar panel details, inverter, battery system details, and microgrid operation calculation. This calculation analyzed for 70 kilowatt total load, which known as total solar power need to operate the system and electrify the rural area at Limbang, Sarawak. The solar panel voltage is 240 volt DC with 87 kilo 500 watt hour per day. Output connected in series parallel. This experiment is to determine either the detail for the solar panel and battery storage change in order to supply enough electricity for the household and to ensure that the total solar power produced is more than total solar power needed. On the other hand, the result from figure 4.3 and 4.4 are quite similar from the result in figure 4.1 and 4.2. This is because the result from the total electrical load from 10 households is 50 kilowatt. Based on the system design, the total solar power after correction factor is 62.5 kilowatt, so the system is suitable and can fully support the rural area at Limbang containing 10 households. The connection of solar panel in series parallel and the number of string is 63 number of string with 20 number of panel in each string. The total power for the PV solar of each string is 100 watt, so the size of inverter needed is 5 kilowatt with 100% efficiency. The battery system storage also in series parallel connection with 150 number of string and 20 total number of battery in each string. Total storage for the battery system is 1500 ampere hour with 2.5 reserve days, and the number of battery for the design is 3000 number of string. As a conclusion, the design and simulation of a solar PV microgrid for Sarawak rural area using Excel Vlookup will surely open up people's eyes to how important it is to generate your electricity energy that also will help to preserve nature a longer term and electrify the rural area which not connected to the main grid. That brings us to the end of the presentation. Thank you for sparing your time to watch my poster presentation. I like to summarize by saying that renewable energy is key for a better life in the future. To be clear and understand, this is a video demonstration that I've provided. So, for this video, I will simulate and explain the details of my project which designed a solar PV microgrid for Sarawak rural area. Target of rural area I chose at Sarawak is Limbang and containing about 10 households. First and foremost, before we analyze the PV solar, battery and inverter details, the consumer need to justify the electrical load for the household. As we can see on the screen, this is the electrical load detail sheet for this project. I have assumed the data for 10 households, which every household capacity is 700 watt times by 10 hours of using per day. So the total electrical load for each household is 7 kilowatt and the total of 10 households is 70 kilowatt. So the total we can see on the bottom of this table. After the load detail was justified, we can go to the main sheet of this Excel to see either the details of PV solar, inverter and battery system were calculated or not. Other than that, this system also needs us to choose the connection of the PV solar and battery system. So for this system, I choose the series parallel connection for both solar panel and battery system. So the connection will okay. And for the design, I assume that the daily sunlight hour is 10 hour average for the, and for the battery capacity, 2.5 days is the reserve day if anything happens such as rainy day, so the PV solar cannot produce any power. For my system, the solar system voltage is 240 volt DC. The losses in wire connection battery is 25%. The total solar power needed is 70 kilowatt as we justify on the electrical load sheet. So the total solar power after correction factor is 70.5 kilowatt. So the total solar power produced is larger than total solar power need. So our design is success. The total solar array after calculating the sun hour is 8750 watt. The size of solar panel is 100 watt and the volt is 12 volt. For the solar panel, the number of string for this design for the load of 70 kilowatt is 88 number of string, and the total watt of each solar panel string is 100 watt. So the total number of solar panel in each string is 20. The total watt of solar panel is 8800 watt, and the total number of string of solar panel is 1760. For the inverter, the efficiency of inverter is 100%, so the size of inverter needed for the design is 7000 kilowatt. Okay, next is battery system detail. The battery bank voltage is 240 volt DC. The reserve day, as mentioned, is 2.5 day. The losers connection is 20%. The battery efficiency is 100%. Battery aging is 20%. DOD for the battery is 50%. The operating temperature of the battery is 27 Celsius. So for the temperature, also we can choose either we use the Celsius or Fahrenheit. So the battery bank requires 2100 ampere hour, and the connection is series parallel. The number of string for battery is 210 number of string. The total ampere hour of each string is 10. So the total number of battery in each string is 20. Okay, so for the calculation, this is the total kilowatt hour per day for the 10 household, which is 70 kilowatt hour per day. So the total ampere hour is 291.0 ampere hour. The average load is 350 ampere hour. The storage required is 875 ampere hour. The battery aging is 1050 ampere hour, including operating temperature, also 1050 ampere hour. And the DOD depth of discharge for the battery is 2100 ampere hour. So that's all for the simulation of the design PV microgrid for Sarawak rural area. Thank you.